Hello, Algebra 2 students. Today we are going to do section 2.6, which is called Draw Scatterplots and Best Fitting Lines. So we haven't talked about writing an equation of a line yet, but we have talked about the slope-intercept form, which is y equals mx plus b. So we are going to use that equation to write our equation of a line. If your data seems to approximate a line, your job is to find the equation of a line which is closest to all the data points. The table shows the number of people, Y, which is the bottom row, who attended each of the first 7 football games, X, in the top row, of the season. Approximate a best fitting line for the data. So these are the steps that you need to do. So as you see from the table, the game is on the top row. It's going to be represented by the horizontal axis of your graph, and Y is going to represent the vertical axis since the number of people. So in part A, as you can see, the graph is already done for you. All the dots were plotted, and then a line of best fit was drawn. So you should probably be asking yourself, how do we draw this line? How do we make it to where, how steep does it need to be, and so on. So the goal is when you're drawing a line, you want roughly half the number of dots above the line and half the number of dots below the line. So if we take a look at this graph, and we look at the dots, we see a dot here, oops, dot there, a dot there, and that's above the line. And if they're on the line, then they're on the line. And then you have this dot here below, and this could count as below. It's okay to have one above or two above and one below, as long as roughly half the amount, half the dots are above and half are below the line. Okay, so I want to erase that. And then go to the next thing. So the next thing, and this is where we're going to start doing our work, is part C. In part C, we're going to choose any 2 points that are on the line. And honestly, we can pick a bunch of these. You can pick this one, you can pick that one. It's pretty much on the line. This one, that one. I'm going to pick the 2 closest. So I'm going to pick 1 comma 722. So I'm going to pick this one, and I'm going to pick that one. But really, you could have picked any of the other 2 dots that I put on there. So I'm going to choose 2 points. I'm going to write those here. So 1, remember X first, then Y. And the other point is, so our second point is 3 comma 772. So those are our points that I've chosen. Next thing we want to do is label them X1, Y1, because that's the first point. And the second point's coordinates are going to have the subscript 2, so x2, y2. And at this point, the first thing we need to do is find the slope, because we can't do anything without the slope. So step 1, find slope. Try not to write too big here. Okay, so that's m. So m equals, if you remember from your formula, the first thing we want to do is put a minus sign in here. Okay, and y2 goes first, so that's 772 minus 722, and the x's go on the bottom, so x2 first, x1 second, and then we're just going to do the math. So 772 minus 722 is 50. 50 divided by 2 is 25. So the slope is about 25. So hopefully you're thinking, why is she saying about when 50 divided by 2 is exactly 25? Remember, all of these lines are the points in the scatter plot are not lying in a straight line, so it's approximate. The slope is not going to be exactly 25 from one dot to the next dot, but it's going to be an approximate average for the remainder of the dots. So that's why I put about 25. Okay, so the next thing we want to do is, remember, in order to write the equation in y equals mx plus b form, we need to know what b is, but we don't know b because this is not a straight line. So we can't get it from the table because there is no 0 for x. And remember, when x is 0, the value for y will be the y-intercept. So what we're going to do is we're going to use one of these 2 points above. We're going to use either 1 comma 722 or 3 comma 772. I like this one. The smaller numbers are better and positive numbers are better. Well, both pairs of points are positive, so you're just going to pick. And so what we're going to do is we are going to replace y with the y coordinate of the point that I just circled, which is 722, equals m we just found was 25, times, remember that's m times x, mx plus b. So x is 1, and it's from the point I circled, and that just leaves us with b, the unknown, the missing variable. So now we're just going to do the math. 722 equals 25 times 1. Please don't add those two numbers. When they're numbers next to each other without a plus sign, and it clearly shows the parentheses, you're multiplying. So 25 plus b, subtract 25, and 722 minus 25 is 697, and that is b. And remember, that's an approximate for b also. So our equation in step D is y equals 25, because remember, slope comes first, times the variable x, plus b, and we just found b to be 697. So, and according to the graph, it looks like the y-intercept is 700, but remember, this is an approximate. So now, based on that equation, we can predict the attendance for the 10th game. So, and because we're obviously not going to know the exact value as it's not a straight line, but we can use the approximate. So y equals 25x plus 697. Replace 25 with 10 because we want to know the attendance, how many people are going to come after 10 games. So 25 times 10 is 250 plus 697. That is 947. So about 947 people. Yeah. All right, so that is a scatter plot. Now let's look at the vocabulary associated with this concept. So a scatter plot is a graph of a set of points. In our football game example, we had 7 pairs of points and we plotted them, and then we had to draw a line of best fit. So the next vocabulary word is best fitting line. This is the line closest to all data points. Okay, there's two types of correlation. Actually, there's three, but we're just mentioning two here, and I will mention the third after we talk about the first two. The first type of correlation is called a positive correlation, and that just says if x increases, y increases. And here's the picture associated with that. So here's this portion. You only need that one portion to draw your one quadrant to draw a scatter plot. So say we have some dots here. Oops. These points are pretty close together that you can actually draw a line of best fit. I just drew one, estimating that's roughly half above, half below. But as you notice, this is the variable x, and this is y. As you go this way on the horizontal axis, y also goes up. Because if this is 1 comma 1, this would be 2 comma 3, or so on. And a real life example could be the more you study, the higher your test grades. So the more you study, so the more time you spend studying, that's X, the higher your test scores, your test grades go up. So that's an example of a positive correlation. Okay, the next vocabulary word is negative correlation. If X decreases, if X increases, Y decreases. Mm, I'll sketch this picture right here. And and I do the line. So an example for this particular one is the more TV you watch, the lower your test scores. So the more TV you watch, that's your independent variable, the lower your test scores. So that's a good example of negative correlation. And there's the third one, which I'll go ahead and sketch. And really, it's just a scattered pattern, which you can't draw a line of best fit. This would be no correlation. There we go. Okay, the last vocabulary word is correlation coefficient. And this particular correlation coefficient is R. So letter R. And R tells us how well a line fits the data. R is between -1 and +1. It's the best fit if R equals 1 or R equals -1. You could have like 0.95, -0.93, just any numbers between -1 and 1 and including -1 and 1. It's the worst fit if R equals 0. If you decide to take AP statistics later on, you will learn all about correlation coefficients. Okay, let's look at the back page of our notes. Let's look at some examples for R values. So these 5 graphs that you see are various correlation coefficients that describe the graph. So if you look at the first one, that is a very good negative correlation, and you can actually draw a line of best fit pretty decently. And you can just imagine how to draw it. So I'll draw this particular one, but just imagine that you want to draw the line so that roughly half the points are above, half are below. This kind of went crooked. So there's a good line of best fitting line. The next one, -0.8, it's still a negative correlation, but the the tightness of the dots isn't as pronounced. So if you could draw a line, but it's just not as great, but still not bad. So there, you can draw a line like that, or you can make it less steep. It's getting trickier. It's still negative. There's still a negative correlation. I'm just going to go ahead and try and draw some of this. But it just gets worse. The dots are going to be farther away from your line. I'm getting pretty bad at this. Next one, I came and draw one. Do I draw one um, with a positive slope or do I draw one with a negative slope? You just can't tell. So R equals 0. And the last one is perfect. All the dots are in a straight line. And this is R equals 1. And it's a positive one. It's a positive correlation. So when r is exactly 1, the data points are all on the line with a positive slope, like the last picture. When r is close to 1, the data points are close to the line and also with a positive slope. And I don't have a picture of that, but just imagine if you know this last picture where r equals 1, if you had something like r equals zero point 0.9, it'd be pretty close. When r is exactly -1, the data points are all on the line with a negative slope. That's the first picture because really, honestly, that's about as close to -1. It's probably like negative 0.99, and the points are really close together. When r is close to -1, like the second picture, the data points are all close to the line with a negative slope. Just think of Mr. Slope Man's face. If the line falls from left to right, it's a negative slope. When r is near 0, the points do not lie close to a line. Okay, we're going to finish up our notes with the following 3 examples. Tell whether the correlation coefficient is closest to -1, negative point, negative 0.5, 0, 0.5, or 1. And the easiest way to do it is to try and sketch your line of best fit. So, mm, that's my line of best fit. So if you see I have 2 points above the line and 3 points below, that's just how it's going to be because it's an odd number. And they're fairly close together. It's not exactly 1, but I would say it's close to 1. We definitely know it's positive because the line is rising from left to right. Okay, next one, how do I even go about drawing a line? Do I draw it this way? Do I draw it that way? I mean, you just can't. There's just points are too scattered everywhere. So this particular one is probably going to be 0, closest to 0. It could be even like point 0.1, but it's closest to 0. And lastly, this particular one, it definitely does not have a positive slope because these points are too far away from the line if we were to draw a line like that. So you kind of have to look and determine how you're going to sketch the line. So for this particular one, we could make something like this, and it's not that bad. And so it is negative, but it's not a really good, strong negative. So I'm going to say this is closest to negative. It's definitely negative, so 0.5 because that was our option. And that is our notes for today. Have a great day, Algebra 2 students.